Hello everyone. Today I'm going to talk about the Pascal triangle. The Pascal triangle is a triangular array of the binomial coefficient. In much of the Western world, it is named after the French mathematician Blaise Pascal. Next, this Pascal triangle is known by the several mathematicians before the birth of the Blaise Pascal. Let us know how we can build this Pascal triangle. Okay? Just start with 1, and on either side of this 0, this 1, we have a azimuth zeros. Okay, this is considered as row 0, and this is row 2, row 1. In this row 1, just add the 0 and 1, we get 1, and 1 plus 0 is 1. For the second row, same way we have to do. Here let us assume the 0 over here, and 0 plus 1 is 1, and 1 plus 1 is 2, and 1 plus 0 is 1. Okay. After that, if we continue like this, we get a Pascal triangle for an infinite rows. Okay, and this is row 3. Now we observe the diagonals of the Pascal triangle which I was written here. Just observe here in the first row and in the last row. In the first diagonal and in the last diagonal we have all the things are 1, and in second diagonal we have natural number, in third diagonal we have triangular number, in fourth diagonal we have tetrahedral number. Let us know what is triangular number and tetrahedral number. The triangular number is a number of dots it takes to make the various sized triangles. Okay, and then tetrahedral number, they represents the number of dots needed to make the pyramids with the triangle bases. After this, the Pascal triangle is reveals about the powers of 2 and powers of 11. Let us know how it reveals about the powers of 2 and the powers of 11. First, do it for powers of 2. Write it on the Pascal triangle up to row 3. This is 1. To the power of 0 is 1. Just add each rows, we get the powers of 2. This is 2, and 4 we get to the power of 2, and 8 which we get to the power of 3. And next, if we continue like this, the powers of 2 is revealed in Pascal triangle. For n through, we get to the power of n. And next, for a power of 11, we get, just write the Pascal triangle up to 5th row, we get here, just write it down, 1 3 3 1, this is 1. Okay, and 4 6 4 1, and this is 5 10 5 1. Here 11 to the power of 0 means 1, and just read it as it is. 11 to the power of 1 we get 11, and here 121 which is 11 square, and this 11 can be expanded as 1 into 10 to the power of 1 and 1 into 10 to the power of 0. This can be expanded as 1 into 10 to the power of 2 plus 2 into 10 to the power of 1 plus 1 into 10 to the power of 0. We get 121. And do it, and further we can do it for this row and this row. Let us deal with this row. Okay, that is 5th row. 1 into 10 to the power of 5 plus 5 into 10 to the power of 4 plus 10 into 10 to the power of 3 and 10 into 10 to the power of 2 plus 5 into 10 to the power of what? 0, right? 1, right? And plus 1 into 10 to the power of 0. We get 1 6 1 0 5 1. This is the value of 11 to the power of 5. From this we come to know that the Pascal triangle reveals about the powers of 2 and powers of 11. Next, let us know what is the hidden sequence in this Pascal triangle. Just once again write down the Pascal triangle here. This is 1 1 1. This is row 0 and row 1, and next is row 2, and next is for row 3, and next one is row 4, and next is row 5. Just stop here. This is enough. In this, add diagonally from left to right, we get the hidden sequence here. Okay. 1 plus 1 is 2, and next 1 plus 2 is 3, and next thing is 5, and next one is what, 8, right? Further it continues. Let us write here what is the hidden sequence here. This is what hidden sequence in the Pascal triangle. This sequence is known as Fibonacci sequence. From this we come to know that the Pascal triangle has a Fibonacci sequence. Okay. Next, this Pascal triangle is also deals with the binomial expansion. Let's know about the binomial expansion. Take a plus b whole to the power of 1. If we expand, we get a plus b. Here the coefficients are 1, 1. For a, we have a coefficient 1, and for b, we have a coefficient 1. In the Pascal triangle, in row 1, we have the coefficients of a and b. The coefficient of a is here 1, and for b, we have a coefficient 1. The same way for a plus b whole square, we have a square plus 2ab plus b square. Here the coefficient is 1, and for ab coefficient is 2, and for b square coefficient is 1. And here in the row 2 we have a coefficients of a square, ab, and 1. 1 is the coefficient of a square, and 2 is the coefficient of ab, and 1 is the coefficient of b square. Likewise, if we continue, we can learn about the binomial expansion. Next, about the Pascal's triangle. Let us write here once again the Pascal triangle. Okay guys, this is row 0, row 1, row 2, row 3. This is for row 5. This is row 5. Okay. Just shade the odd numbers. Shade all the odd numbers. Okay. All the odd numbers. We get a Pascal's triangle.